Today I'm going to go over a basic overview of IP addresses, what they are, what they're used for, what has them, and then very basic, simple conversion from IP addresses in the human readable form to binary, which is how computers read them. I'm not going to go into any subnetting or classful IP addresses. I just want to go into the very basic conversion of human readable IP addresses to binary IP addresses. I'd like to start by saying, for the first time ever, I'm recording this off of my phone. I found an app. It's called DU Screen Recorder. It's pretty cool. I think at the bottom of the screen you can see it's tagged itself. But it's a very cool app in which I can record off of my phone. I can use my phone to draw. I'll use my little stylus, in which I'll go into the conversion of IP addresses into binary later. But it's a very cool app. I highly recommend it if you get the chance to look into it. So, what are IP addresses? IP addresses are, in a sense, like the address to your house, both in the literal sense, in which you can use an IP address to generally locate where a house or whatever is using that IP address is, and then in a figurative sense, in that it's just a means to communicate over the internet. If you think about it, the internet is almost a roadmap, and you can think of it as a country. If you're holding a big old map, IP addresses and how the internet works is there's different roads to different places. If I wanted to travel from the west coast to the east coast, there's 1,000 different ways I can get there. Some have faster ways, some have slower ways, some have different stops in between, and that's basically, in a sense, how the networking portion of the internet works. Every website you go to, say for example www.google.com or facebook.com, every single one of those websites has an IP address associated with that website. There's different ways you can find the IP addresses of those websites, like nslookup.com, and I'll show you real quick. I got it on my computer. I'll pull up. Let me open up the camera real quick on my phone. A simple command you can do is if you go into your command shell, so all you have to do is type in Windows CMD, enter, and it'll bring up this command shell. And you just do nslookup www.google.com, and it'll actually show you some of the IP addresses associated with google.com. So if I simply copy one of these IP addresses, paste that in a URL, as opposed to the google.com we're used to. So I just paste in the IP address. It's going to pull up google.com, and I can do that with any website. So back to what IP addresses are. Every single device out on the internet has an IP address, whether that be your phone, the websites you go to, smart TVs, pretty much anything. Originally, in the late 1970s, researchers, when they wanted to come up with IP addresses, they came up with a 32-bit form, which gave them the possibility of, I forget the exact number, I want to say it's 4.29 billion IP addresses. At the time, they thought there was no way possible to run out of those IP addresses. With modern times, and don't quote me on this, I want to say there's roughly 7 billion people on the internet, and a lot of those people are using multiple devices, whether it be their phone or their computer or what have you. They've started to realize that they are running out of spaces for IP addresses. So if you look on your computer, if you're connected to a home Wi-Fi, chances are you have what's called a private IP address. Or even your home router. Chances are, if you've ever had to log into your home router, chances are you had to type in your URL the 192.168.0.1 or .1.1 IP address. What those IP addresses are, they're called private IP addresses. They are non-routable through the internet, and your computer as well. The 192.168 IP address it pulls, and I'll show you an example on my computer. Let me open up my camera again. Through my handy dandy new app I just got, you can see I opened up my command prompt, and I have it up here. I have it scroll down a little bit. My IP address of my computer is a 192.168 IP address, and that in itself is a private IP address. It's non-routable through the internet. So your home router, how it works is your ISP generally gives your home router its public IP address. And if I can draw it out for you. So here's your home computer. It's your laptop you're sitting at, scrolling through Facebook or doing school or whatever you're having to do. You know, you're connected to your, whether it be wireless or wired, your home router. Let's just say that's your home router. And then your home router is connected to the internet. You know, on the internet you've got Google and Facebook and .edu and any other website you want to go to. So generally your home computer, in a way to save the 4.2 billion IP addresses, they give it a 192.168 IP address. Same thing with this side of your home router, the 192.168. When it goes through your home router and it hits this side, it changes itself into whatever your ISP, whether that be, you know, Verizon or Time Warner or whoever is charging you every single month, they give you a public routable IP address. So, you know, let's just say it's 20.20.30.40. That is your public IP address. Anytime you want to get out to Facebook.com, you go from your computer to your home router, you hit your public port, go out to the internet, you hit Facebook server way over here. Let's just call it Facebook. You say, hey Facebook, my IP address is this one right here. They'll get your information. They'll send it back to that IP address, and because your router knows that you sent that packet to Facebook.com through the port it associated you with, it'll send that back to your personal computer, which is a very, very, very general overview of what IP addresses are. And just to go back and clarify, you have a public IP address, which is generally the a private IP address, which is generally the 192.168 IP address, which will never go on the internet. And then you have your public IP address. And to look at your public IP address, there's websites out there you can go to, like if you just do a real quick Google of what's my IP, it'll give you back some crazy results. It'll show you your IP address that's you're assigned, and it'll even show you a general location of where you're at geographically. A lot of the ISPs give you an IP address, and that's associated with the geolocation of that IP range. So now what I want to go into is basically breaking down the 4 octets of an IP address and transitioning that over to binary. So let me erase this. Getting a little more in the weeds of IP addresses. What they are, so let's go back to our 192 example. And how you would say that is 192.168.0.1. That's just the general grammar that's used when talking about IP addresses. Each number in those dots are called octets. In every octet, they have 8 bits. 8 equaling oct, obviously. So let's just say this .1. These are the bits associated. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits in every octet, and there's 4 octets in an IPv4 address, which is common to what you see right now. They're transitioning over to something called IPv6, and that solves the issue we're having with how many possible public IP addresses there are. In IPv6, I couldn't even tell you how many there's like 16 untamillion, or they gave some crazy example like 7 IP addresses per every atom and every human. It's some ridiculous amount that as of right now they're saying we'll never run out of. So going back into our octets, Let's start with the 1. In these individual bits, they all represent a different number value. And to quickly go over it, they double every time. So this first little bit equals 1, this one equals 2, double 2 equals 4, 8, 16, 32, 64, and 128. All of those numbers added up will equal 255. So what that means is you will never see an octet with higher than a number of 255. 255 is the highest number in each octet you'll see. You'll never see 256, 257, so on and so forth. So as you can see, this 1 goes with this 1 block right here. And what I'm getting at right here, and sorry to backtrack a little bit, because computers cannot read what humans can, they transition everything over to 1s and 0s, little bits. Either it's a on electromagnetic pulse, or it's an off one. So 1 being on and 0 being off. So how it would read this last octet, it would be 0, 0, 0, 0, 0, 0, 0, 1. That's how it would read it. If I was to go over it, let's do the 168 block. If I was to do that portion of the IP address, let's do the math. So 128 goes into 168. Yep. 128 plus 64 equals 192, so nope. That one's going to be off. 128 plus 32. 128 plus 32 equals 0. 160. So that one's going to be on. And the only other one we have on is 8. So 0, 1, 0, 0, 0. And how the computer would read it, it would just read it in basic octet forms. It would just break down the octets and do 1s and 0s. And that's why if you've ever heard anybody say, you speak 1s and 0s, that's basically what they're referencing, is transitioning everything over to binary. As the weeks go on, I'm definitely going a little bit more in detail with this, and we'll do subnetting and then routing and how that stuff works. I hope this very, very, very basic overview of IP addresses and transitions over to binary have been helpful for you guys. Please like and subscribe my YouTube channel, and if there's anything you guys wish to see, any videos you want me to do, please let me know. Thank you for watching.